Here in just another minute. All right, good afternoon, everybody. Thank you for joining us today. Today, we're just going to be sort of going over an overview of our wireless LAN products. We're going to start by talking about some of the unique features of our hardware, talk a little bit about the software that we've got going on. We'll talk a little bit about Wi-Fi 6 and Wi-Fi 6E. And then we'll also go through basically all of the access points that we have briefly, just sort of explaining some of the key differences between the different models. As we go through today, if you have any questions, please use the question and answer box in the Zoom interface. I cannot see hands being raised. I cannot see chat. So send them in using questions and answers. And depending on the question, I will either answer it as we go through or I will save it for the end of today's presentation. So we're getting started here by talking about our wireless access points. So this is something Zyxel's been involved in for quite a long time. We got started with Wi-Fi back in the 802.11 days, before 11B or 11A, just 802.11. We used to sell wireless products back then, and we've continued to do it ever since. So we've been going on here, what, close to 23, 24 years of making wireless products. Now, when you look at our access points, we've got three main types of antenna technology that may be included on an access point you are looking at. The most common here is a static antenna. So that is going to be your traditional fixed antenna. Generally, those are designed so that when you mount the access point on the ceiling, it spreads the signal out and down, covering the area directly below the access point and out from it. We have dual optimized antennas, and we also have smart antennas. So this is just showing you here, here's your traditional ceiling mount access point and the sort of antenna pattern you would expect to get from it. Now, one of the challenges we run into out there in the real world is that sometimes you don't get to mount on the ceiling. Sometimes you end up having to mount on walls. And when you do that with the traditional access point, the problem you run into is the antenna pattern has been optimized for the idea that the antenna or the access point is above the area to be covered, rather than being rotated perpendicular to it. So what happens is a lot of your signal goes up into the ceiling, a lot of it goes into the floor getting wasted. If you're in a multi-story building, it can cause interference with your neighbors on the floors above or below you, etc. So our solution to this is that dual optimized antennas. And basically what we've done is we've put in two sets of antennas in these access points that have this feature. One set that is one antenna that is designed for ceiling mount, one antenna that's designed for wall mount. And then we give you the ability to choose on a per AP basis which antennas you want to use based on where you've installed that access point. So that helps optimize those your access points based on where you've done the installation. The other technology we have here is our smart antenna technology. Those of you that have sold Ruckus in the past or familiar with Ruckus, it's similar technology to their BeamFlex or BeamFlex Plus. And the idea behind it here is to increase capacity. So the number of clients you can have on an access point before you start running into interference issues, increasing the coverage so the access point can cover a wider area. And it's been designed to reduce interference. In fact, that's a main area where we've bet a lot of our focus, which is different from some of the other vendors out there. So the way smart antenna works is, again, your traditional access point just has one fixed antenna that covers the area below it. And the problem is when you run into interference, whether that be other access points operating on the same or nearby channels, or whether we're talking about other wireless devices or even industrial equipment, things like microwaves, which can put out RF interference, those can cause interference. So with our smart antenna technology, Instead of having that one fixed antenna pattern, or like our dual optimized antennas, having two antenna patterns, instead what we have here is we have hundreds of antenna patterns. So we've got the ability in basically real time to go through hundreds of different antenna patterns and choose the one that's ideal for where the client device is in relation to the access point. But ours also takes into account sources of interference and helps choose an antenna pattern that ignores other sources of interference. And again, it doesn't matter if it's something like a microwave in this example, or if it's just another access point that's operating on a similar channel. So that way, you're by forming and aiming the beam at where the client device is, you focus the power to the end to the client device, so the signal is better, so you get a better signal to noise ratio. But then at the access point level, we have the ability to essentially be able to ignore certain other sources of interference. So here's just a quick example of a test we did. We compared our WAX 650S access point to an Aruba 515. Both are Wi-Fi 6 access points that support 4 spatial streams on the 5 gigahertz radio. Our performance is in green, theirs is in blue, transmit and receive. And so see, as you can see here, it doesn't matter if you're transmitting or receiving. It makes a huge difference in a real world environment where there are going to be other sources of interference out there. Now, a number of years back, a group here out of the University of Brescia in Italy, their networking group decided to test some of the claims vendors like us and Ruckus made about smart antenna technology. So they've put together a full report. There's a link there. I believe that link still works. It'll take you to the full analysis and all the testing and details and stuff they've done. But the quick short version of it here is smart antenna technology in real world and dense environments is going to have up to a 70% performance advantage over non-smart antenna access points. And when it comes to dealing with interference, we performed up to 45% better than other vendors. If you simply go on Google and type Zyxel white paper smart antenna, we have a white paper that summarizes the key points on this and gives you something you can give to your customers to explain it real easily. Or of course, you can always pull up the official link and go through all the details of all the testing and results. So we'll go through some of our technologies here, and these we're going to be focusing on Nebula since that's what most people are using these days to manage our access points. It should be said our access points, all of them can work in standalone mode or can be managed in the Nebula cloud. And some of our access points can also be managed with a local area controller. But for today's presentation, we'll just focus on the cloud features. Features are pretty much the same between the cloud and a local controller. So really easy to set up and support wireless mesh. It's literally just something you can turn on. And access points will then automatically go into a mesh mode. So you can have coverage in areas where you don't necessarily have a hardwired backhaul to those access points. And our smart mesh has the functionality also to primarily work using a wired connection. But if something happens and the wired connection goes down, those access points that have lost their connection can automatically put themselves into mesh mode so that they can find a way back to a access point that still has a working wired backhaul so your end users don't lose connectivity until that problem gets solved. Another cool feature we have here is called dynamic pre-shared key or dynamic personal pre-shared key. So one of the challenges what we run into out in the real world when it comes to businesses is right. The ideal way of doing things is you want to use 802.1x authentication on your wireless users. Each wireless user gets their own unique username and password, and they have to authenticate with that to get onto the network. It's really good when you're dealing with, a business with multiple employees. So that way, when a user or an employee gets fired or leaves the company, you simply turn them off and it doesn't affect the other users. Unfortunately, because setting up 802.1x and getting it working on clients can sometimes be a bit of a chore, there's a lot of businesses out there that are just using one pre-shared key for all of their users. So dynamic pre-shared key basically gives you the ease of use of a single password for everybody to use while giving you a uniqueness to it and security that you would normally get with traditional WPA enterprise security. And so basically the way this works is instead of having to worry about configuring an 802.1x client on the client device and username and password, you simply give each of your employees their own unique password. They all connect to the same SSID. They have their pre-shared key password, which they enter just like they would any other pre-shared key to get onto a wireless network. And then when they authenticate, our wireless access points confirm that back with a Radius server or our cloud authentication server. And then you can assign VLANs and things like that based on the individual user. And if you're using our Nebula Pro solution, we have the ability to use artificial intelligence and machine learning to automatically make changes to your wireless network as we see any sort of issues or connectivity issues with the wireless client. So if we see there's an area or a certain client that's having issues, we can make adjustments to the way the wireless network is configured automatically to help solve those issues without needing to get you involved. And then when we're dealing with our access points here, basically everything that's in our 110 series and higher is this what we call an RF first design. So all of our access points, even our cheap little NWA 1123 ACV3, which sells for like I think $80 or $90, follows this philosophy. And that's why we're able to offer lifetime warranties on most of our access points, where most of our competition that we're competing with doesn't. And that comes to this here. So one of the things you'll see is on our access point here, if you pick it up and hold it in your hand and you hold one of our competitors, even one of our more expensive competitors, you will notice ours weighs more. So why is that? So we've got a large metal shield that goes behind the PCBA. So this acts as a heat sink, drawing heat off the board and venting it out of vent holes in the top of the access point. If you look at some of our cheaper competitors out there, they don't even have vent holes to let heat out. And that's a bad thing. And it's one of the reasons why they offer only a 1 year or 2 year warranty, is because over time with a solid state component like this, if the heat builds up too much, it can cause failure, either failure of the solder joints or failure of the individual little switches that are part of the microchips on the PCBA. So our designs pulls that heat off the board and vents it out, making sure the board doesn't overheat. Another thing that we do on our products here is we do not use any electrolytic capacitors. So those are capacitors that are filled basically with a little bit of cloth material and salt water, and they can dry out, they can leak, they can boil over, causing failure. So we only use solid state capacitors on our access points to make sure they can last a long time. Another area where you will see difference is you will see a lot more shielding on the chips than you would see on some of our competitors' products. The reason for that is this RF first design, and it's not just to help reduce EMI on the board itself. We also build in there 4G and 5G shielding to prevent 4G and 5G signals from interfering with your Wi-Fi. A lot of your cellular signals out there border the 2.4 or the 5 gigahertz space used by Wi-Fi, and you can have edge bleed over, which causes interference. This is especially true of your larger buildings where cellular signal doesn't penetrate. So they're using some form of DOS device to distribute the signal inside the building. So you can have a DAS broadcast, just a few feet down the hallway from where your access points may be, and that can cause interference. Our shielding helps prevent that. The last thing we do, which is very different here, is we don't mount the antennas directly onto the PCBA like most of our competitors. Instead, our antennas are usually mounted on their own board that is separate from the main PCBA, and there's generally a shield between those two boards. That provides just that much better isolation for these antennas from any sort of EMI that might be coming off the main board. And this other board here also acts as a reflector to help strengthen the signal coming into the access point. So that gives you just that much a little bit better signal to noise ratio for that much better of a solid connection, especially for those weak clients. Another sort of cool feature we have on some of our access points here is the ability to turn an access point into a cloud managed VPN appliance. So this is really handy now that we've got a lot of people working from home, whether dedicated or as part of a hybrid type environment. One of the challenges you run into is getting them securely back onto the local network here at your business. And this is how we do it here is we take an access point that's part of a Nebula managed site, um, and we give that access point to the user. They take it home and they plug it into their existing router, and it works as an access point with a special SSID. Now that SSID is set up here using enterprise security and two-factor authentication. to make sure, nobody hacks into it or connects to the corporate network that shouldn't. But once you've connected to that SSID, you've done your two-factor authentication, you've now essentially got a VPN connection from the access point back to the office. So all you have to do when you go home is connect to that same SSID you use at work, authenticate, and then you'll be able to access all of your work appliances and tools and resources as if you were still sitting in the office. So the easy thing with this is it's cloud managed and there's no configuration that needs to be done on the end user's computer or the end user's router. You simply plug it into their existing router. You don't have to worry about double natting causing issues and things like that. So it's a great tool to be able to provide easy VPN access for remote users. And then we do have a number of access points specifically designed to be able to be used in an outdoor environment. On the low end here, we have our NWA 55AXE, great for doing, short point-to-point links between buildings and providing basic coverage, primarily at a home or for a small office. We have an outdoor enclosure that fits a lot of our access points and allows you to essentially cheaply turn one of our indoor access points into an outdoor access points for providing coverage. And then we've got our dedicated heavy duty outdoor access points, the WAC 6553D-E and the WAX 655E. Both of these are in super heavy duty IP66 rated enclosures that can handle temperatures down to -40 as well as hot temperatures. So depending on what features you need, we've got these two options available for you. So now I want to move on and talk briefly about Wi-Fi 6 because it is still a fairly new technology out there and it builds into Wi-Fi 6E, which we'll talk about later. So Wi-Fi 6 was one of the first major overhauls to Wi-Fi and how it works since 1999. Basically, since 1999, very little has been done to change the core way that Wi-Fi 6 works. And there's been a lot of problems that have been plaguing us since then, right? Because how we use the network, how we use wireless has changed dramatically in the last 23 years. So Wi-Fi 6 set out to try to change that and solve some of those issues. Basically, between now and then, primarily the main thing that we'd been focusing on was increasing the speed of the wireless network and nothing else. So this is now how we've tried to solve some of these issues. So it is designed to be faster. So it is going to be faster than your 11AC products, but it's also been designed to be higher capacity. So that means more client devices on the same access point without running into those issues that you run into with 11AC and older technologies. It's also been designed so you can have more APs in the same area and designed to minimize the interference between those access points. In addition, Wi-Fi 6 is dual band, meaning that it improves the performance of both 2.4 and 5 gigahertz. Essentially, the feature set is the same regardless of what frequency you use. And Wi-Fi 6 was designed so it could easily be ported to any other frequency that opens up, which leads us in a minute here to Wi-Fi 6E. But this is particularly important because 11AC technology was only on the 5 gigahertz radio. If you were running an 11AC router or access point, that 2.4 radio in there is still using 11N technology. So a big improvement in theory for your 2.4 radio for you to use. And Wi-Fi 6 in theory can support speeds up to 10 gigabits per second. We don't offer any access points that go up to that speed, but it is theoretically what it has been designed to support. Now, a key thing here to talk about when it comes to Wi-Fi 6 is a lot of the features in here are optional. Some of what I would consider core features didn't even become something that was part of the Wi-Fi Alliance. You had to support to be able to get that Wi-Fi Alliance certification for your product. So that's something to keep in mind, is that some of the access points out there are missing some of the Wi-Fi 6 features. And unlike 11N Lite or 11AC Wave 1 and Wave 2, there is no differentiator in the naming to make it easy to tell which are full true Wi-Fi 6 and which are not. Another thing that's out there is some of the competitors out there have only put Wi-Fi 6 on the 5 gigahertz radio and are still shipping with a 2.4 that's 11N technology. Ubiquity's U6 Lite, for instance, is one of those access points. So that's something to keep in mind. When it comes to Zyxel equipment, All of our Wi-Fi 6 products are Wi-Fi 6 on both radios, and all of our 110 series and higher, those true business class access points, have basically the full Wi-Fi 6 feature set. So just something to keep in mind when you're shopping around, when you're looking at our products. So just to show you here, just a quick slide, this is showing you a big difference here between Wi-Fi 6 and 11AC. So what happens with 11AC, which is this darker orange bottom line here, and this is showing us the aggregated throughput of all the connected clients. And over here, we are seeing basically how many clients are currently connected. And what you'll see is as you increase the number of clients connected to the access point, the aggregated throughput is going to drop. And that just has to deal with, the fact that Wi-Fi traditionally has not been designed to have lots of users. And so as you add more and more users, it actually uses the available airtime less efficiently. You get a lot of interference issues, drop packets, and you see the overall performance drop. Where with Wi-Fi 6, basically the aggregated throughput is going to remain flat no matter how many wireless users you put on there within reason. So now we'll start talking about the different access points. And we'll start off here. We're now trying to split up our products into three different categories here: simplicity, flexibility, and ultimate. So the first one we'll talk about here is the simplicity section here. So these are products that are really aimed at that prosumer space, SOHO, a lot of the do-it-yourselfers out there. So they are going to be missing some features. These are all Wi-Fi 6 access points, but they are missing some of the Wi-Fi 6 features. They're missing some of the Nebula features, and we will talk about those differences here in an upcoming slide. But at the very bottom end here, we have our NWA 50AX. This is an Amazon-only SKU. It is not available through distribution. It's an AX 1800 indoor AP. We have the NWA 55AXE, which is an outdoor version of this. The main difference between these two, other than indoor versus outdoor, is the outdoor version does support the ability to do basically point-to-point links. So if you need to bridge buildings together, you need to bridge a second building to the first one, you need to bridge a barn or a shed to your main home, this is a product that you can use to do that. And then going a step up here is the NWA 90 and NWA 90AX Pro. So these are available through distribution, but they don't qualify for our partner discount program. Very similar to the NWA 50 as far as the hardware goes. It's just a little bit different in the software. And again, I've got a slide coming up where we'll talk about those differences. The 90AX Pro is something that's launching this month. It's just now become available through distribution for you. And it's a little bit confusing because the technology is a little bit different than this. Basically, it and the 90 are the same access point. They both support 2 spatial streams each. However, the Pro is an AX 3000 class product, whereas the non-Pro is an AX 1800 class product. So how are we getting faster speeds if they both only support 2 spatial streams? And the answer to that is the new Pro model supports 160 megahertz channels. So that essentially allows you to double the speed with the same number of spatial streams. Now, the challenge with this is that also means you have to have available 160 megahertz channels to be able to use, and your clients have to support those 160 megahertz channels. So basically with 5 gigahertz, with 2.4, you can't support 160 megahertz channels. With 5 gigahertz, there's only 260 megahertz channels available. So you're only going to want to use this in a home or a very small office where you aren't worrying about interference from your neighbors, because as soon as you add a third access point, there's going to be some interference issues because of the overlap in the channel usage. And then in addition, there's a lot of the client devices out there don't support 160 megahertz channels, and they do need to be able to achieve those faster speeds. And then to support those faster speeds, we've upgraded the LAN port on this to a 2.5 gig LAN port instead of just a 1 gig LAN port on the non-Pro version. Going up there to our flexible line, this is where we get into our true business class access points. So this is going to be the 110 and higher series on the business side of things. For our older Wi-Fi 5 products, which I don't have in here, that would be the NWA 1123 ACV3 and the WAC 500. So these can be managed standalone or with our Nebula cloud. So the entry-level model here is our NWA 110AX. So again, it's an AX 1800 product, but it's a little bit more heavy duty. And again, I will have a slide talking about the differences here between this and the 90 and the 50. Step up from that is the NWA 210AX. which doubles the number of spatial streams on the 5 gigahertz radio from 2 to 4. So this jumps from an AX1800 to an AX3000 product. And again, we've also upgraded the LAN port to 2.5 gigs. And then our new guy here, the NWA220AX-6E, which is our Wi-Fi 6E product. And we'll talk a little bit more about Wi-Fi 6E and the differences between those models in a little bit. So what I've put here is a slide for you showing you all of the AX1800 access points we have, because it can get a little confusing. Right, we've got 5 different access points here, all of them with AX1800. So can you what is the difference? So on the 50 and the 55, again, this is aimed primarily at the prosumer space. It's a 2x2 AX1800, but you'll notice on the Wi-Fi 6 side of things, the MU-MIMO, which is a technology that's part of Wi-Fi 6, only works in the downstream direction. OFDMA only works in the downstream direction. Same on the NWA90 here. So those are some of the features that are kind of missing on the Wi-Fi 6 side of things. It'll hurt performance a little bit compared to a 110 or 510 access point. Also, when it comes to security, the 50 and the NWA 55 do not support WPA Enterprise. They only support WPA Personal. The 90 then adds the ability to support WPA Enterprise. And then some of the other features that are available on the 90 that are not part of the 50, MAC authentication, radius authentication, captive portal. So again, if you need to provide a captive portal for guest access, the 50 series doesn't have that. And then they also do not have layer 2 isolation, which is part of the 90 series. So jumping up here from the 50 and 90 to our true business class access points, one of the main differences here is going to be the warranty, lifetime warranty on the 110 and 510 versus just 2 years on the 50 and 90 series. And then the business class access points here, the 110 and higher, add a number of other business class features that you probably are looking for most business installations. The ability to do AP load balancing, the ability to use dynamic personal pre-shared key, the ability to do NAT on an SSID basis. So you can put different SSIDs on different subnets that are NATed, the ability to use SNMP to be able to monitor your access points, the ability to use artificial intelligence to automatically optimize your wireless network, and support for our CNP Plus, which is our security access point hosted security service that we offer as an optional add-on. So those are the features that you get on the Simplicity series here, the 110 and higher, that are missing from the 50 and the 90 series. Let's keep going here. So going up from there is our Ultimate series. So these are access points that add for you what we would call Nebula Flex Pro. So they become bundled with 1 year of our Nebula Pro license. So that's a license that unlocks some additional features in the cloud that's primarily aimed at MSPs, gives you email alerts when products go offline, gives you automatic topology view, a number of features like that, which I cover in our Nebula presentation. So for here, we've got the WAX 510D and the WAX 610D. These add the dual optimized antennas. That's what the D on the end of the model line has there for you. So that's the differences. So the 510D would be very similar to the NWA 110 with the addition of that Pro license and the addition of the dual optimized antennas. The 610 would be very similar to the NWA 220, but again, with adding the dual optimized antennas for you in that Pro Pack license. And then the new guy on the block here, the WAX 620D-6E. Stock is kind of low on these at the moment just because we've been giving them away with our switch promo that we've been running. But we will have more of these coming in, and that's going to be our Wi-Fi 6E product that has the dual optimized antennas for you. Jumping up from there takes us to the WAX 630S and WAX 640S. So these are smart antenna access points. Those, if you're looking for that smart antenna technology, this is where you want to jump up to. And then these just give us better speeds here. So this is going to be a 4x4, so very similar to the 610, but adding the smart antenna technology to it. And then lastly here, the WAX 650S. This is our flagship product. It's no longer the fastest. The 640S with Wi-Fi 6E is faster, but it is still the fastest you're going to get on 5 gigahertz, fastest speeds we can get on 2.4 gigahertz. It also adds a dedicated monitoring radio for 5 gigahertz utilization. So if you're using those DFS channels, the monitoring radio can allow you to quickly change channels without the downtime you would normally run into when dealing with DFS and being forced to change channels due to legacy devices. It's also got the ability to support Bluetooth BLE. So you can use those for those advanced retail applications where you use BLE for targeted push notifications. Okay, so now I'll talk a little bit more about Wi-Fi 6E, since this is the latest and greatest technology. So basically what happened is the FCC opened up 6 gigahertz. So previously the 6 gigahertz frequency required you have a license in order to be able to use this channel or those channels. So Wi-Fi 6E has now been opened up. So now we can support and use unlicensed Wi-Fi on these 6 gigahertz channels. And that's what Wi-Fi 6E is, taking Wi-Fi 6 and extending it to the 6 gigahertz frequency here. So it gives us a tremendous amount of new bandwidth available for us. And we don't have to worry about interference because basically nothing else is using this except for Wi-Fi. Now there are legacy users, licensed users who had this Wi-Fi, or excuse me, the 6 gigahertz usage for their equipment. It was a lot of utility companies, news reporters, things like that were using 6 gigahertz and continue to use 6 gigahertz as a licensed spectrum, but they are doing it outside. And Wi-Fi or 6 gigahertz doesn't penetrate walls very well. So you shouldn't have to worry about any sort of bleed in from anything going on outside causing issues for you. But that does lead us to one key thing when it comes to Wi-Fi 6E and 6 gigahertz usage is essentially at this point, 6 gigahertz can only be used indoors. There is a new technology that is going to be part of being able to use 6 gigahertz outdoors. It requires you use a third-party service to be able to geolocate where you are, what channels you are currently using, and what channels other people, legacy users, may be using. So it can basically have you switch channels if a legacy user comes into the space that you're at, or to prevent you from using a channel that's currently being used by a nearby legacy user. That is under still testing by the FCC. It has been slowed down because there are lawsuits from these legacy users trying to block the use of outdoor 6 gigahertz Wi-Fi. So until those systems officially get ratified and approved by the FCC and the rules are finally formalized, 6 gigahertz is just an for indoor applications, not for outdoor applications. So just to show you here, the main benefit of 6 gigahertz is how much available spectrum is available. As you can see here, 6 gigahertz has more available bandwidth than 2.4 and 5 gigahertz combined. So we were talking about before 160 megahertz channels. As you can see here with 5 gigahertz, you've only got 2 available that everybody has to share. When it comes to 6 gigahertz, there are 7 available for everyone to share. So you're going to be able to have a lot more 6 gigahertz devices in the same area before you run into code channel interference issues where you've got 2 or more devices using the same channel overlapping and causing interference. So it's going to be fantastic for those type of environments. But again, the range is less than 5 gigahertz. So that is something to keep in mind when you're doing your deployments. So basically the main areas or use cases for 6 gigahertz is high density environments, places where you're going to have a lot of users in the same space. I imagine this is going to be very popular in expo centers and conference rooms and things like that, where you've got a lot of users in there, or for applications that you need really high bandwidth and low latency. So those are the main areas where 6 gigahertz is going to be a benefit. Now the trick with 6 gigahertz, of course, is the client devices also have to support 6 gigahertz. So it's something that right now, is slowly trickling out. You see it on your flagship phones and maybe some of your flagship laptops, but it's going to be a while before 6 gigahertz support is ubiquitous. So that brings us here to our 6E access points. We've talked briefly about them in the past. Now, the main ones here are affordable ones here are the NWA 220AX-6E and the WAX 620D-6E. Both of them are AXE 5400 series products. These support 2 spatial streams on the 2.4 radio and 4 spatial streams on the 5/6 gigahertz radio. Now, the way these are done is these are what we would call band flex. So what that means is this access point can either use 5 gigahertz or 6 gigahertz. It cannot use both of them simultaneously. So this helps keep the price down. We don't need as powerful of a SoC running things because it's only dealing with 2 radios. We don't need 2 sets of hardware or 3 sets of hardware in there for everything. So the idea behind these access points is to make 6E affordable, so you can easily add 6 gigahertz to an existing network without replacing all of your access points. Just add in these 6E models in areas where you need or will benefit from that 6 gigahertz coverage. Or alternately, use these today because, again, most client devices don't support 6 gigahertz. And then in the future, when 6 gigahertz is much more widely supported, you can always switch, turn off that 5 gigahertz radio and enable 6 gigahertz instead. Now, if you want to provide coverage on 2.4, 5 gigahertz, and 6 gigahertz all at the same time, the solution to that here is the WAX640S-6E. That supports all 3 bands at the same time, and it also comes bundled with our smart antenna technology. So lastly here, we'll do just a couple of quick hardware comparisons showing how we compare to some of our competitors. So we'll start here with the WAX510D. So you can see here, we're competing against the Aruba 505 and Ingenius's 357 or ECW 220. So we have dual optimized antennas. The other guys just have that standard ceiling mount antenna in there. We have higher output power than both of our competition on both the 2.4 and the 5 gigahertz radio. Same speeds between all 3 models here. Same uplink ports on them. And then a key one here is the Ingenius is not providing Wi-Fi 6E. They're using an early generation, or excuse me, not providing full Wi-Fi 6. They are missing some of those Wi-Fi 6 features like BSS coloring, upstream OFDMA, upstream MIMO, which are present in the WAX510D here. And then lastly, we'll just do really quick here, our flagship, the WAX650S. This competes with the Meraki 45, the MR45 there, the Aruba 535, and the Ruckus R750. So that's where we're going to be doing our main competition here. So basically, us and Ruckus are the only ones with smart antenna. Cisco, Meraki, and Aruba don't offer that smart antenna technology. We have better output power than all of our competition on both radios here. We've got the uplink port is a 5 gigabit uplink port on this model, where most of our competition here is 2.5 gig on the uplink, including on the Ruckus. And then, of course, our model here supports both local management, cloud management, and standalone operating modes. And with that, guys, that's the end of today's presentation. I hope it wasn't a little too dry for you. I know it's not the most exciting topic to be talking about here. If you've got questions, again, send them in using that question and answer interface. In the meantime, while I'm waiting for some more questions to come in, just to highlight for you here, we do have a YouTube channel. Since Zyxel is a huge multinational company, there's lots of different Zyxel regional channels on there. So the one for North America is called Zyxel America channel. Most of our webinars are recorded and uploaded there. So if you miss one or have to duck out early, you can always find it uploaded generally the day after. On our YouTube page also has video case studies, some best practices videos, and other guides and things like that. So it's something to check out. And then if you want to connect to us on LinkedIn, we are Zyxel US channel. And then lastly here, I do want to highlight for you that we do have a user forum. You simply go to forum.zyxel.com, and that's a place where you can reach out to your other Zyxel installers and users. These forums are monitored by our R&D and our product management team. So they will see feedback that you post there, feature demands, things like that. And occasionally they will wade in and answer specific questions that you may have. It's also one of the best places to go to for notifications about security issues, release notes, things like that. Great place for those to go. Paul says here, you had charts on output power. Can we add receiver sensitivity or is that too hard to get? It's out there. I know for our products, if you pull up the data sheet, we always have the sensitivity on our data sheet. It's just not something people generally are asking for, but it is there on the data sheets. And in general, when we do these comparisons, when I look at them, generally the receive sensitivity isn't that different between the different vendors, at least what they're putting on their data sheets. Most of us are going to generally be in the 99 to 103 range. So I hope that answers that question here. So does the WAX 50, I think it's supposed to be the 55 AX or 50, does the AX, excuse me, does the 50 AXE support P2P and PTMP? Okay, so the Model 50, the NWA 50AX, the indoor access point, it supports mesh, I believe, but it does not support tunneling. So you won't be able to create a point-to-point link with it. The 55 AXE, the outdoor one, that does support tunneling through the mesh. So it will do point-to-point. I believe it will also do point-to-multipoint. I'm not 100% on that, but for sure it does point-to-point tunneling, but I think it also does the point-to-multipoint. Okay, so Eric's answer, he meant the 55. So yeah, so I think we've got that covered there. And then Joe was asking, does the WAX 640S support that what do we call it here? The VPN feature on the access point. Sorry, my mind has gone completely blank on the official name of that feature. We've actually got two names we call it by, and I can't remember either of them at the moment. But yeah, I'm pretty sure the WAX 640S does. The cheapest access point we have that supports it is the WAC 500, which is our 11AC Wave 2 access point. And then I believe all of the other models above that do support it. It's secure Wi-Fi. That's the term I was looking for. Secure Wi-Fi. And then there's one other name for it, depending on whether you're looking at materials from our wireless division or looking at materials from the security division. Now, in order to be able to use that, you do have to be managing your customer's network in Nebula. No, you don't have to have it in Nebula. It's available in Nebula. It's also available in non-Nebula mode with our security appliances, but you do have to be using one of our compatible security appliances as the gateway at the site that you want people to be able to connect back to. So it is a two-part solution there. You do need the Zyxel USG Flex or ATP gateway. You need a compatible access point, and then you need the license that unlocks that feature. So hope that answered your question. I know I got sort of confused myself there for a minute. So hopefully I didn't make that too. And so Eric is asking about point to multipoint. Send us an email. You can send it to me. My email is up there on the screen right now, seanr@zyxel.com, SHAWNR@zyxel.com. And I can confirm that for you. Or alternately, I'm assuming if you're here, you're one of our partners, you can always reach out to your salesperson, Jacob, David, Andy, whichever one it is for you. Send them that question and they can get you the answer as well. So either way, I'll be happy to answer the question, whether it comes directly to me or through one of the sales guys. And I think that is it as far as questions go. If there's something that pops up later here, again, feel free to email me or just send the question to your sales guy and ask them to forward it to me or to our sales engineer, and we can help answer that question for you. But thanks for joining us. I hope to see you at one of our other future webinars that we do. Thank you.